All right, we're moving on to 11.3a, dividing polynomials. Wait, there's no sleeping.
Miss May, I'm so sleepy from spring break though.
Okay, for the bell work, we're reviewing long division back in the day. So for long division, I'm doing 6. How many 6s goes into 762? So let's review this process. The first thing you do is you think, how many times does 6 go into 7? 6 only goes in once, and then 1 times 6 gives us 6, and then we subtract down. 7 minus 6 gives me 1, and you bring down the 6. Again, now you're thinking 6 into 16. How many times does 6 go into 16? That would be twice. Put the 2 there. And then you do 6 times 2 is 12. And then we subtract down. 16 minus 12 is 4. And then we bring down this 2. And then again, this process is you think, how many times does 6 go into 42? 6 goes into 42 7 times perfectly. So then if we subtracted, we would have no remainder. So then 762 divided by 6 would give me 127. So that process is really important. We're going to be doing that a lot today. But first, we're talking about dividing by a monomial. That means one term, right? It's this polynomial divided by this monomial. In this process, we don't want to do long division. All you have to do is divide each thing individually by 3x squared. So I take 9x to the third, and I divide it by 3x squared. Minus, I take 6x squared, and I divide it by 3x squared. Again, last term, plus 15x divided by 3x squared. So when you're dividing by a monomial, you just do each term divided by that monomial. And now I simplify. Let's see. 9 divided by 3 is 3. X to the third divided by x squared. The x squareds cancel, or you could think about subtracting. X to the third minus 2 here would be just x. Minus 6 divided by 3 is 2. The x squareds here will perfectly cancel, so there's no longer an x. Here, 15 divided by 3 is...
Miss May, question.
Yes.
Wasn't it 15x?
Woo, good catch there.
Yay.
Woo. Forgot the x there, good catch. So here, 15 divided by 3 is 5, and then the x divided by x squared, this does not become x on top, it'd be x on the bottom because the bigger exponent is on the bottom. Boom.
Wow, awesome.
Any questions?
No, looks great.
Feeling good. All right, dividing by a monomial, you divide each term. Go ahead and try this practice problem on your own. Welcome back. Okay, I'm sure you guys did awesome. Here we go. Dividing by a monomial, one term. I divide each of these by my monomial. Plus, then 10a squared. Divided by my monomial. Then positive 3a divided by my monomial. And then I just simplify. 4 divided by 2 is 2. A to the third divided by a squared would just become a on top. Plus 10 divided by 2 is 5. Here the a squareds perfectly cancel, so I'm just left with 5. Here 3 divided by 2 does not do anything, so I leave that. And then the a and the a squared would cancel to give me a on the bottom because the bigger exponent is on the bottom. Any questions?
No, looks great.
All right, that was too easy, right?
Easy.
On to the back. All right, on your homework, I want everyone to write pillow because Mr. Deshane thinks he can just sleep, so we got to throw pillows at him. So on your homework, please write pillow so I know that you're watching the videos. All right, here we go. This is a little bit challenging, but I know you can all do it. So, polynomial long division. So we're going to do the same process we did on the front for bell work. It's just going to be a little bit more complex. All right, we have this polynomial divided by this binomial. So we write it out as long division. D plus 3 goes into 3d squared minus 4d plus 13. So the second number goes on the outside of the bars, and then the bigger polynomial goes inside. All right, I'm going to go through this process slowly. So just like with long division, you do, how does the term get into the term, right? Like in the bell work, all you want to focus on is the front number. So how many times does d go into 3d squared? Well, I need a 3, and then d, I need another d to get d squared. And then I think back, d times 3d would give me 3d squared, so that looks good. You ignore the 3 for now, so now I'm multiplying d times 3d, I get 3d squared. And now I do 3 times 3d. 3 times 3 is positive 9, and then I have a d on the end. So I want to make sure this makes sense. You do front letter into front term. I need a 3 and I need a d. And then you multiply this 3d times both of these, and that's what goes underneath. Now, just like with long division, we need to subtract. But I'm subtracting both of these terms. So what you want to do is you need to change the sign. So I'm going to change that to a plus. This becomes negative, and this becomes negative. So both terms change sign because you're subtracting the whole thing. Okay, now we subtract. Those would cancel. And then a negative 4d and a negative 9d would give you negative 13d. Okay, that's the first step. Now we do it again. Front term, d into 13d. Oops, I forgot one step. Don't forget to bring that extra term down, just like with long division. Okay, back to what we were doing. How many times does d go into negative 13d? Well, I need a negative 13, and then I don't need a d because it already has a d, so it's just negative 13. I make sure, let's see, d times negative 13, good, gives me negative 13d, that's what I want. And then I do negative 13 times 3, negative 39. Now we subtract the whole thing. So everything will change sign. Now that's positive 13d and positive 39. Then these would cancel. Positive 13 and positive 39. Let's see, 12, add the 1, 4, 52. Now, I'm thinking how many times does my front variable go in, or term go into that number? That would not go in because I can't take away a d. So this is called a remainder. And then if I rewrite this is a key step here, how you'll see it on the answer key. So I have 3d minus 13. And then for remainders, it would always be, you say, here's a positive 52, and it should have been divided by d plus 3. So instead of writing it as r52, you write it as a fraction because it should be divided by that d plus 3. So make sure you rewrite the remainders as a fraction of what you originally divided by there. Any questions?
Do we always have to have a remainder?
Not always. If these perfectly canceled, then you would not have a remainder and it would just be that.
Awesome.
Here you do have a remainder, so you want to rewrite it as a fraction.
Sweet.
Okay, I know that was challenging, but try this practice one on your own. All right, I know this is challenging, but you guys can do it. I have faith in you. So m plus 1 goes into the polynomial here of 2m squared minus m minus 3. So there's your setup for long division. Again, you're focusing on the first term into the first term. How many times does m go into 2m squared? Well, I need a 2, and I need another m to get m squared. Again, I double check. M times 2m, good, is 2m squared. And then I do 2m times the 1. Okay, now we think we have to subtract down. So I'm subtracting this whole term, so I put it in parentheses. And then for subtracting, I need to distribute the negative in. So this becomes a plus. Now that's negative, now that's negative. And then we simplify down. Now these cancel, which we expected. And then negative m and a negative 2m would give me negative 3m. I bring down my minus 3, just like with our process of regular long division. And then again, I'm focusing on front term into front term here. So for m, to get into negative 3m, I need a negative 3, and then I don't need anything else because this already has an m. I double check. Negative 3 times m is just negative 3m, so that's good. Negative 3 times 1 is a negative 3. And then I subtract the group. So, Mr. Deshane, what do I do from there?
Distribute the negative.
Yes! So make that a plus. These change sign. And then this is that special case.
Yeah.
Those would cancel, those would cancel. So you have a remainder of 0, which we don't really need to write. So then my answer would just be 2m minus 3. Again, no remainder because everything cancels, which is the best situation you can have there. All right, let's try the last example here. So I'm doing 3x minus 2 into the polynomial here of 6x squared minus 13x plus 2. Okay, let's do this one more time. Front number into front number. So 3 times what gives me 6? 2. And then x times what gives me x squared? X. And then we double check to make sure we get 6x squared. 3x times 2x, yeah, that works out. I get 6, and then x times x is x squared, so that's good. So I'm doing 2x times that, boom, 2x times negative 2, negative 4x, and then I subtract down. When you're subtracting, you distribute the negative, so every term changes sign. As we expect, those cancel. Negative 13x and a positive 4 is negative 9x, and then I bring down my plus 2. Again, main idea here is you need to think front term into front term. 3 times what gives me negative 9? It's a negative 3, and then they both have an x, so I'm good with that. So now I multiply my negative 3 times both of these. Negative 9x, which we expected, and negative 3 times negative 2 is a positive 6. And then I subtract the group. Boom. Distribute the negative, everything will change sign. As we expected, those cancel. 2 and a negative 6 gives me negative 4. Again, 3x into negative 4 would not happen, so this is a remainder. So let's practice writing that out. So I have 2x minus 3. For remainders, I have a minus, so negative 4, so it's minus, and then you do 4 over what you originally divided by, 3x minus 2. I want to reiterate that. Whoops, lost him. So when you have a remainder, again, 3x can't get into negative 4. This would be minus because it's negative, and then you do 4 over what you originally divided by. Any questions?
Nope. Can I go back to sleep now?
No, you can do the homework!
Yay! Okay, I'll do that first and then I'll take my nap. All right, bye.